Did you know it took over 2 millennia for the Pythagorean theorem to be used in calculating distances with the Cartesian coordinate system? This fascinating journey highlights the gradual interconnection of mathematical concepts over the centuries. Pythagoras, who was born in 570 BCE, was an ancient Greek mathematician and philosopher best known for the Pythagorean theorem. First, let's draw a right-angled triangle and label the sides. The two legs are A and B, and the hypotenuse is C. Theorem states that in a right-angled triangle, the square of the lengths of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides. Or let's say, if we create squares on each of the triangle sides, the area of the square on the hypotenuse will be equal to the sum of the area of the other two smaller squares. There is a legend that claims the Cartesian coordinate system was discovered when René Descartes was sick in bed. As he was staring up at the ceiling, he saw a fly. He wondered how he could describe the fly's position on the ceiling. He assumed if the x-axis runs horizontally and y-axis runs vertically, then the point where the x-axis and y-axis intersect is called the origin or reference point, denoted as 0. As a result, the plane is divided into 4 regions known as quadrants. Each quadrant is determined by the sign of the x and y coordinates of the points within it. For example, in quadrant 1, both x and y are positive. Let's explain the movement of a fly in this plane. Suppose the fly starts at some point and moves to the next point. To address the new position of the fly from the reference point, it moves 9 units horizontally to the right and then 5 units upward vertically. So the final position of the fly is 9, 5. Using this system, each point in the plane is uniquely identified by a pair of numerical values, typically referred to as x and y, making location and plotting intuitive. Now is the perfect time to reveal that the distance formula is essentially a direct application of the Pythagorean theorem. Here's how they are connected. Let's consider 2 points P and Q on the plane. Drawing horizontal and vertical lines from P to Q creates a right-angled triangle where the horizontal and vertical lines form the legs and the line segment PQ serves as the hypotenuse. The length of the horizontal leg is x2 minus x1 and the length of the vertical leg is y2 minus y1. According to the Pythagorean theorem, PQ squared is equal to the sum of the squares of the lengths of the other two sides. Now, by taking the square root of both sides, we get the distance formula. There we are. Now, in order to strengthen our knowledge, we can use the formula to calculate the distance between any 2 points on the Cartesian plane. By substituting the x and y coordinate of the points into the formula and then simplifying the expression, the final result is 2 times the square root of 5.